Hey, Garrett.
Hey.
How are you?
Good.
Good. Do you have something specific you would like to work on?
Well, first I have a question.
Okay.
Those work that we were given in class, do we have to complete those as well?
Can you tell me what they were?
One of them's called quadratic functions, and it has like like an arch on it.
Okay, so it's like a doodle sheet.
It has a graph at the bottom, some pictures, and
Talking about the same thing, okay?
and then the other one is like a word game. Like you have like equations, and depending on your answer, you put a different letter into the chart, and you get like a word or something.
Oh, like a riddle?
Kind of.
Okay, I think
It says, how can you
so.
guarantee that you will get straight A's this year? And it has the chart at the bottom where you put the numbers in.
Huh?
Did you give out those papers, or was that just Miss Wen?
No, I did, but now I'm trying to remember what that was called. But I do remember. La da 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 da.
Are we doing those in class, or are these something we have to complete at home as well?
I think that you were supposed to complete them, maybe start them in class and then complete them at home. But man, I wish I could remember what the name of it was. Fiddlesticks. Can you tell me, did it have to do what was the goal? Like, was it graphing or was it factoring?
There's a question. It's like there's a chart and there's 3 columns. One of them is really, really long. That's where the equation is. And the first one's x squared plus 7x plus 12 equals 0. And then if it's -4, -3, put a B in the chart. And if it's -5, -2, you put a W. And it goes down the chart. And then at the very bottom of the page, it says, how can you guarantee that you will get straight A's on this year? And then there's a chart, and it goes 1, 2, 3, 4, 5, 6, all the way through 13. And then for every question, whatever answer you got, you put that letter in that column, and it's supposed to spell out an answer.
I kind of do remember that. But do you know if you're supposed to factor?
It just says determine the solution to the quadratic equations.
Okay. That helps me a little bit. I think I found it. I don't even know. I can't even remember if I gave this to mine. I was supposed to. What did I call it? 1.3, 1.4 quad solve. 1.3. I didn't. You know what? Hold on just 1 minute because I need to upload that to my drive because I only have it on my computer. So I'm sorry. It might take just a second.
I'm not asking to work on it. I'm just asking if we had to do it today.
Oh, I apologize. Yes, you do.
Okay.
I'm sorry.
If I have time, I'll do those last because I really want to work on the book work right now.
Okay. All right.
3 through
So
30.
I'm gonna not take up our time then uploading it until you need it, if that's okay.
Okay.
So you would like to work on 1.4 book work that's on the lesson plan for today. Is that correct?
Page 29, 3 through 35.
Yes, sir.
Yeah, that's what I want to do.
Does that look familiar?
Mm-hmm.
Okay. All right. Now, here's another semi-negative thing. I think she taught it by grouping. Is that correct?
I don't remember.
Okay.
Just consider that I have no idea what I'm doing.
Okay. How bad are you going to hate me if I show you a different way? Could we try it a different way? And then if you hate that, I'll try to recall what she did, because I can factor by grouping.
I haven't learned one way yet, so.
Okay. So you would be okay if we do it this other way?
Yeah.
Okay, great. Yikes. Mine is kind of a rhyme type of thing. It's called slide and divide. And it's really pretty much based on Mom, what are you making? Or is that Caleb's? That's Caleb's. Love you. Love you. Be careful. All right. So I'm going to start with 3. Mine's kind of based. Some pieces and parts of it will look very familiar to you, based on the factoring. How do you feel about factoring when the coefficient is a 1? Are you okay with that?
Yeah.
Okay, good. All right. Well, this is called slide and divide. And so the first part, you're going to slide. And when I say that, I mean you're going to slide this 2 down and multiply it by that 3. Okay, to get rid of it for just a minute. So then that would leave you x squared plus 5x plus 6. Okay?
Can I write this down?
Now that looks more familiar and a lot prettier, right?
Should I write this down?
I would, yes.
Like, not on just notes, but I mean like for the problem solving?
Yes, I would go ahead and write it down for the problem solving. Let's kill 2 birds with 1 stone. Learn and do. So okay. Now, I mean, you just will have a little bit more work on these. You know what I'm saying? On your actual doing. So now what we're going to do is what 2 factors of 6, when you multiply them together, give you 6, but at the same time, when they're added.
Should I put 2 parentheses?
Yes, sir. That when you add them, you would get 5.
You have to buy him lunch when you become an engineer. Buy his house.
3 and 2?
Yes.
So x plus 3 and x plus 2.
Yes. Okay. Now we're coming to the divide part. Okay. Mm-hmm. So that, you remember how we slid the 2 down earlier to multiply it by the 3? Remember that part?
Yeah.
Okay. We're going to divide each one of these by 2. The same thing that you multiplied that 3rd coefficient or that constant by earlier.
So if it was a 3, we'd divide it by 3.
Yes, sir. Okay. So now when the fraction turns out to not be pretty, like that 3 over 2, you come over here and you bring that 2 there. So that's going to be 2x plus 3. And that stays in parentheses. And then this one, 2 over 2 reduces to 1.
Mom, where's that $12 thing?
So that's your final answer.
I'm done with the problem now.
Did you find it?
Is it attached to this?
Do you feel it?
That's it.
Sorry.
I'm sorry. I had to help Mackenzie with something. I apologize. Yes, that's your final answer. At least for the factoring ones. Later on, when you actually have to solve, which I think is, I don't remember what part that is, but it's down below, like at, I think starting with number 32 or something like that. But the very first part, all we have to do is factor. But we'll cross that bridge when we get further down.
Okay.
But does this kind of make sense to you?
Yeah.
Okay. I know that she does it a little bit differently than I do. She does it via grouping, which, you know, that's great too. But for me, from an understanding standpoint, I feel like this is very consistent. So let's just continue working through the problems. Was it odd or was it all of them?
3 through 35 odd.
3 through 35 odd. I better write that down. All right, let's move on to number 5 then. Are you good with this?
Yeah.
All right. I think the more we do this, Garrett, the better you'll understand. We'll just keep working them. And I'm going to keep asking you questions and you kind of talk through it with me. And I feel like it'll become a little clearer each time. It's a practice kind of thing. You know what I mean?
Yeah.
Okay. All right. Number 5. We have 4r squared plus 5r plus 1. We're going to slide that 4 on down to the 1. Okay. And rewrite it. Oops, my bad. Rewrite it with r squared plus 5r plus, and then 1 times 4 is
5 or 4.
4. Yeah, I got you. Okay. So now what we're doing is looking for 2 factors of 4 that obviously when they're multiplied together, they get 4, but when we add them, you would get 5. So that's going to give you 4 and 1, correct?
Yeah.
Okay. So now we would have r plus 4 and r plus 1. Okay?
Okay.
And now we did the slide. That's that first step. And now we're at the divide step. And we divide by the leading coefficient from the original problem, which was 4. So we divide each one of those by 4. And remember, when it's kind of a nice, pretty factor like that, 4 divided by 4 is what?
1.
Mm-hmm. Now, this one, not so pretty. So we bring our denominator over in front of the r.
4r plus 1.
R plus 1.
I get it now.
Okay, so that's the final answer.
I'm just dreading what's after it.
It's not going to be too bad. We're going to be so well practiced at this, Garrett. When we hit that part, it's not going to be a big deal. I promise. It's not going to hurt a bit. Okay, so moving right along, what do we have? 7 is next, right?
Yeah.
Okay. 11z squared. Is it z? Am I looking at it right? Okay. Plus 2z minus 9. So our first step is slide. So we're going to multiply 11 times negative 9. So that's going to leave us with z squared plus 2z minus 99. So the first thing that we need to do is look for 2 factors that when multiplied together give you a 99, that when you combine them together, you get a positive 2. So a couple things to think about is that I know one's going to be positive and one's going to be a negative of those 2 factors, because only when you multiply a negative and a positive do you get a negative.
Is it 11 and 9?
Yes, it is. And the bigger one has to be the positive one. Does that make sense to you?
Mm-hmm. So it's
Okay,
plus
good.
11 minus 9.
Yes. There's no stopping you. Z minus 9. Okay. So now we've done our slide. We've done our factoring. Now we have to divide. And we're going to divide the leading coefficient, which was 11, by both of our factors. And so the first one turns out kind of pretty. So that's going to be Z plus 1 because 11 divided by 11 is 1. But this one, not such a pretty one. So we've got to bring that 11 to the front of the Z and leave the 9 there. Not too bad.
So number 9.
You feeling more confident with each one that we do?
Yeah.
Okay, good. Sorry, it takes me a minute to get all of that erased.
That's fine.
9. 4y squared minus 5y minus 4. So we're going to slide, and that's going to give us 16, a negative 16. So it's going to be y squared minus 5y minus 16. So two factors that when multiplied together give us 16. That when we add them give us a negative 5. So the things that I know is that the I don't think this one can be factored, is that it's going to be negative, but let's think about it. We got 16 and 1, so that's not going to work.
Is it
We've got 8 and 2, so that's not going to work. I don't think it's factorable.
So I just write non-factorable?
Not factorable. Can you think of one? Okay, so we've got 16 and 1, that doesn't work. 8 and 2, that doesn't work because that would give us 6. And then 4 and 4, and that doesn't work because that technically would give us 0. I don't think it works. What do you think?
I don't think it does.
I can't think of any other factors. So you would write not factorable there?
Mm-hmm.
Because the instructions say factor it, and if it's not possible, say so. I think that, isn't that what is that right?
If
Read the directions.
be factored, it says if the expression cannot be factored, say so.
Okay. And number 9, yeah, I just looked in the answer key. It says cannot be factored, so we were right. Yay. Okay, so gone with that one. Away with you. And now we're on to number 11. Okay, it is 9d squared minus 13d minus 10.
It's d squared minus 13d minus 9d.
Yes, d squared minus 13d minus 90. Good job. You already slid. Okay, so two factors that multiply together to give you 90 that when you combine them give you 13. So let's see. There's so many factors of 90. There's 30 and 3. There's 45 and 2. There's 9 and 10. Let's see. There's more. There's more.
Mm. I don't know.
Oh, that's a humdinger. Okay. I'm going to do something with you. Hopefully your brain won't shut down on me. I don't know if you can see my little birthday cake method thing that I do here, but this is how I factor. I'll redo it. And I do it this way so that I can see all visible factors of a number. So what I do is I start with the smallest prime number, which is 2, and 2 goes into 90 and leaves me 45. Well, the 2 does not go into 45, so the next smallest prime number is 3, and 3 goes into 45 and gives you 15. 3 will also go into 15. I stay with that same prime number, and 3 goes into 15 5 times. So if I'm factoring 90, I could do this as 15 and 6, which that wouldn't give me the answer that I need. But lo and behold, if I multiply, oops, not 9, my bad. If I multiply, I had it just a second ago. It was 27, what I had earlier. Oh, here it is. It's 18. Okay, so 9. So believe it or not, 18 and 5. Because 3 times 3, oops. 3 times 3 times 2 is 18. So these 3, which makes 18, and this is 5. So that
So 18 and 5 are the answer for this?
yeah. So yes. So D minus 18 and D plus 5. So now we have to divide. Now we now we're to our divide part. And D, 18 divided by 9 is 2. And I bring this over and I have 9D plus 5.
This makes a lot more sense now.
And that's my answer. Oh, good. I'm so glad. It's just sometimes finding the actual factors could be the tricky part. You know what I mean?
Mm-hmm.
But, oh, I'm so glad that it makes more sense. All right. So did you get this one down?
Yeah.
Okay, good. All right. So now on to 13. Okay, 13. Right?
Mm-hmm.
Okay, now these are all more of the special factoring. And they're special, but these are pretty easy. Okay, let's take a look at it. The first one, this is called the difference of 2 squares. So what I can tell you, because it's a special factoring pattern, you can put your parentheses down. And what is the square root of 9x squared?
3.
Yes. So 3x is going to go in both places. And then you take the square root of 1, which is what?
1.
Uh-huh. And you'll do plus 1 in one and minus 1 in the other. And this is called a special factoring pattern. And I don't know if she talked about this yesterday. I'm talking about this more with my students tomorrow. And this is called the difference of two squares. Okay? And it's this way every single time. There's a plus in one and a minus in the other. But the way you check it is to find out if the first number is a perfect square and the second number is a perfect square. And then it will always have this pattern. And this is a very, 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 I cannot stress to you how important this really is. Because when we start working on this weird stuff in advance and as we move forward, we're going to be working with something called a conjugate for complex numbers. And it's all that conjugate stuff is based on the difference of two squares. So it's really, really important. And I want to explain how this is done. If I were to go ahead and FOIL this out, Garrett, by using the FOIL method.
You get the problem we just got?
Yes. The most important thing to note about this is you would get plus 3x minus 3x and then a minus 1. See this piece right here?
Cancel.
That's what cancels out. And it's because there's a plus here and a minus there. So that's the most important thing. Okay?
Okay.
All right. I cannot stress this enough because it's going to be this whole principle. There's so much in math, in trig, in complex things that the difference of two squares or perfect squares is based on that, these principles that we're talking about right now, which is called special factoring. Okay?
Okay.
All right, let's work on a few more to make sure it's solidified. That was 13. All right, let's look at 15. So we have 49 n squared minus 16. So what's the square root of 49 n squared?
7.
7n. Because you can't forget that pretty little variable. Okay, so there's going to be a plus in one, a minus in the other. And what's the square root of 16?
Oh man, I'm so tired. 4?
Yes, 4. Good job. So that's your final answer. Does that make sense?
Yeah.
Or not really?
Makes sense.
It might make more sense if you weren't so tired. I know that feeling. Woo. The struggle's real some days. All right, now, this next one, this is a perfect square.
I'm sorry if I sound kind of tired. I just have a tendency to talk monotone.
Oh, no. You said you were tired, so I was like, you told me you were tired, so I was assuming
I sometimes come off as uninterested or just gloomy.
Oh, I wasn't worried about that. You go, oh, I'm so tired. So that's what I was basing it off of. On this one, this is called a perfect square trinomial. And what you're going to notice about that is let's take a look at this first number, 49x squared, and this number, 25. Those are both perfect squares. This one being 7x and this one being 5, right?
Mm-hmm.
Okay, so, but it's not the difference of two squares because because there's no, that 70 would be not there if it was, right? And there'd be a subtraction sign, but there's a number there. What you want to do to confirm that it is actually a perfect square binomial, what's 7 times 5?
35.
Times 2.
70.
Yes. So that number right there tells me that this is going to be a perfect square. This is a perfect square trinomial, and that's what it looks like. Does that make sense? Or not really? I'm sorry?
That's the answer.
Yes, sir.
What would you do if it wasn't?
If you mean if that 70 wasn't in the middle?
I mean, if the 70 didn't work out with the 7 and 5.
You'd have to do the slide and divide, or use the quadratic formula or something like that. You're going to hope and pray that it actually works out. But 9 times out of 10, Garrett, I'm just going to say in math, it's probably going to work that way, but you do want to double check. But if I were you, when you're looking at these problems and you see that the leading coefficient is a perfect square, I would always check the C, which is that last constant, and I would go ahead and jot those down and then figure out what those two multiplied together times 2 would be. But I'm going to tell you, in the book, they write it like this: a squared plus 2ab plus b squared. That's the factoring pattern. So this would be the 7 squared, 7x squared. This would be the bx squared. And then that's the 70. That's the a and the b times each other. Doubled. That's how you would recognize the pattern. But we'll work a few more, and hopefully that will make it, more clear. Just a few more to make sure it's clear. All right, what was that? What number was that one? 17?
Mm-hmm.
Okay, 19. Okay. 9p squared minus 12p plus 4. Okay, now here's an interesting thing. On this one, what is the square root of 9p squared?
3.
P. Don't forget the variable. Make sure you don't forget that. And now, but this one right here, that's a negative. But my final one is a positive. But 2 negatives multiplied together would give you a positive, right?
Mm-hmm.
It's just going to tell me that my last is going to be a negative. Okay? Now, just to confirm that this is, in fact, a perfect square, what's 3 times 2?
6.
And what, and actually it's 3 times negative 2, so it would be negative 6. And then 2 times negative 6 is what?
Negative 12.
So that does work out on this one. Does that make sense?
Yeah.
Or not really?
It makes sense.
Okay, good. Sometimes I always wonder on this thing if I explain this one well. I think I do a better job on the difference of 2 cubes or 2 squares. I don't think I always feel a little fuzzy when I'm explaining. All right, so let's do 21. Okay, 36x squared minus 84x plus 49. Okay, what's the square root of 36x squared?
6x.
Good job. All right, now, this middle term here has a negative on it. So that tells me that the number, what's the square root of 49?
7.
Okay.
Yeah.
So 7. So in this particular case, though, I need to put a -7 because I know that two negatives added together is going to give me that, right? So that's what determines that number in the that sign in the middle. Does that make sense to you?
Mm-hmm.
Okay. So now 6 times 7, -7 is what?
42.
So -42.
That
And
equals
-2 times -42 is -84. So that one works as well. So the final answer, oh, and Garrett, I don't know that I've been doing this every time. You should have a little squared outside that parentheses.
You've been doing it.
Have I done that every time?
I've written it down.
Oh, praise God. You knew to do it. Thank you so much. Bless your heart. Okay. All right, moving right along. In the next section, what we have to do first is get a common factor out. Okay? So starting on, because we finished that section, right? So starting on number 23, we have 18z squared plus 36z plus 16. Okay, well, I can look at the front and know that that's not a perfect square, but I can look at all three values, like the 18, the 36, and the 16, and I know that they have a factor in common. Do you know what factor that would be? What could I factor out of all three of those numbers?
I don't know.
They're all even, so I can factor out what? If something's even, you can always factor what?
2.
Correct. A 2. So if I take a 2 out of 18z squared, what do I have left?
9.
9z squared. And if I take a 2 out of 36z, what would I have left?
Oh man. What's half of 36 again?
18.
I was gonna say that, but it didn't sound right.
Yeah, 18z. And then if I took a 2 out of 16, what would I have left?
8.
Yes, good job. Okay. Now,
All right.
yes, I would write all that down. Now, my leading coefficient is a perfect square, but that last number, number 8, is not a perfect square. So I know I don't have a perfect square trinomial. So I've got to move on to the next thing that we learned. I do have a leading coefficient, so I'm going to slide and divide. So I have to keep my 2 in there, but this is going to give me z squared plus 18z plus 72. So now I want to come up with 2 oh Lord, please help me to think. I've just lost all my words, Garrett. I'm so sorry. 2 factors that when multiplied together give me 72, that when I combine them give me 18. So let's see. 2. So let's see. Eight and 9. I'm manipulating these, trying to figure it out.
I need to go get something. I'll be right back.
Okay. Ah, I found it, I think. $12 and $6. Yay.
Okay, I'm back.
Okay. I figured out what the factors were. It's 12 and 6.
Yeah, that does make
And
sense.
I'm sorry?
I said, yeah, that makes sense.
Okay, so, and I'm really glad that we got to this one because this is going to be an interesting one. Okay, so we've done our slide, and now we're going to hit our divide. Okay, so we're dividing by that leading coefficient, which was a 9. Okay, because we don't go back to the very first step because we've already factored that 2 out. But if you'll look at 12 divided by 9, I can reduce that fraction. Okay, and that's going to be z plus, and that's 4 over 3. Okay, it's still not pretty, but it is reduced. And then z plus, and I can reduce this fraction, 6 over 2, or over 9, and that's 2 over 3. Okay, and now once your fraction is reduced, you move it to the front. So I have 3z plus 4, and then 3z plus 2. Okay?
Okay.
Does that make sense?
Mm-hmm.
Okay. Even when you have to reduce the fraction to its lowest terms and everything?
Mm-hmm.
Okay. Oh, good. I'm so glad. That's a really good example problem too. What number was that? Number 23? I'm going to write that down and make sure I do that in class tomorrow.
Give me a second. Someone's calling the phone.
Oh, yes, yes.
I didn't recognize the number.
Love those unknowns. Okay, so now we're on 25.
Mm-hmm.
Once again, just always looking for that greatest common factor first. So we've got 6u squared minus 24u. And believe it or not, this one is a lot simpler than it seems. What is the common factor that can be taken out of 6u squared and negative 24u?
6.
6 is one of them. And what else? They both have a letter in common.
Oh, u.
Yes, u. So when I take a 6u out of 6u squared, it leaves a u. And when I take a 6u out of negative 24u, it leaves 4. So that is factored in its least form, to the smallest that it can be factored. Okay? So don't let sometimes we get so tripped up when we're factoring really complicated ones. They throw in a simple one like that, and it kind of trips us up.
I don't get that one.
I'm sorry?
I don't get that one.
You don't get that one?
Where'd the 4 come from?
Where did the 4 come from?
Yeah.
Okay. When I take 24u and I divide 6u out of it, what would that leave me with?
Okay, I get it now.
Okay. Sometimes it helps to see it. So a lot of times when you have something really, really simple like that, like what will happen on a worksheet inevitably or a test is that you have all these really complicated trinomials that you're factoring, and then you get to something that's this simple and it's like, oh my. And I do remember, I think there's something like that on one of the tests that's given. So in this chapter, unless we took it out, I can't remember. Let's see, 27. That's 20x squared plus 124x plus 24. So I know I can take a 2 out of that. But that's still going to leave me with all even numbers. So now I'm going to try, because that would leave me with 10 and 62 and 12. So I know I can take another 2 out of that. So that's 2 times 2 is 4. So I'm going to take 4 into all of it and see how that goes. I'll start there. So if I take a 4 out of 20x squared, that leaves me 5x squared. And if I take a 4 out of 124x, that leaves me with 31x. And if I take a 4 out of 24, that leaves me with 6. Does that make sense?
Mm-hmm.
Just factoring a 4 all the way across. And now I'm going to slide and divide. So I got to bring down my 4, but that's going to rewrite this as x squared plus 31x plus 30. So now I want to come up with 2 factors, and praise God, it's an easy one this time. 2 factors that when multiplied together are 30, that when you add them are 31. And that's going to be 30 and 1. And now I've already done my sliding. So now I'm going to divide, and I'm going to take that leading coefficient that I had originally slid down to the C, and I'm going to divide my factors by that. And that's going to be 4. And then this 30 divided by 5 reduces very nicely. The 1/5, not so pretty. So I'm going to take my 5 and make it my leading coefficient on my factor plus 1. How was that one?
Hold on.
Okay.
Wait. Okay. Okay, I get it now.
Okay. So, so have you been writing down all of our work just to make sure when you go back through, it's good?
Mm-hmm.
Okay, good. What number was that one?
27.
Okay. Is it a little better than when we started from an understanding standpoint?
Yeah.
Okay, good. I'm so glad. Praise the Lord. All right, so 29. So negative 36n squared plus 48n minus 15. Well, I notice that 36 is a perfect square, but 15 is definitely not. Plus, I have that negative on the front of the 36. So that doesn't really work. So I cannot factor a 2 out. My first two terms, this one and this one, are even, but I can't factor a 2 out because 15 isn't even. But I can factor a 3 out because 3 goes into 36, 48, and 15. So because that leading coefficient is a negative, I'm going to try to get rid of that, and I'm going to factor a negative 3 out all the way across. So negative 3 goes into negative 36 and leaves me a positive 12n squared plus, oh, oops, not plus, because if I take a negative 3 and divide it into 48, it's going to leave me a negative 16n. Is that right?
Mm-hmm.
Yes. And then minus 5 because negative, plus 5 because negative 3 goes into negative 15 a positive 5 times. I'm trying to make sure that I factored it down all the way as far as I could, and I did, because nothing can evenly go into 12, 16, and 5. Like 4 will go into 12 and 16, but it definitely won't go into 5. So I've got it. I've got all the greatest common factor. This is called factoring out the GCF of the trinomial first. So now I can slide and divide because my leading coefficient is not a 1. So I'm going to multiply my 12 and my 5. So that's going to leave me n squared minus 16n plus, and then 12 times 60, 12 times 5 is 60. So now I'm going to look for two factors that multiply together to give you 60, a positive 60, but when you combine them, give you a negative 16. Which that's going to be a 10, a negative 10, and a negative 6. And now I'm going to go back. I've done my slide. Now I'm going to do my divide step. And I notice that I can reduce the fractions, so I want to get those to their smallest terms. So that's going to be 5 over 6 on this fraction. And it's going to be 1 over 2 on this fraction. Now, I don't want fractions in my factors, so I'm going to move my 6 to the front on this factor and move my 2 to the front on this factor. Hey, Brooke or Caleb, can you please take guess out back? to use the restroom? Okay. All right. Does that make sense?
Yeah.
Do you like the slide and divide method?
Yes.
Okay. Was there a part of that that you feel like you couldn't do on your own?
Not really.
Okay, good. Let's see. What number was that one? 29?
Yeah, we're on 31 now.
Okay. So error analysis. Describe and correct the error in factoring the expression. Can you tell what it is?
They didn't do anything to the 36.
Right. So what they tried to do is they were started with the intention of factoring out the 4. But they only factored the 4 out of the first part and not the second one. If they would have factored the 4 out of the 36, that would have left them what?
9.
Yes.
But yeah.
Right. You were right. So they could. So what they wanted to do is factor out the 4, that greatest common factor, which is fine. But if you're going to factor out the 4, you have to do it from both terms. Right?
Mm-hmm.
All right. So now this is still the difference of 2 perfect squares. Right?
Right.
Okay. What's the square root of x squared? Is x. Do you know what the answer to this one is? It's one of those special factoring patterns. That square root of 9 is what?
X minus 3, x plus 3.
Yeah. Good job. I think I wrote it opposite of what you said it. Sorry. But yeah, that's it. So when they factored the 4 out, they should have factored it out of both numbers or both terms and then gone with the perfect squares from there. And now we're on 33. Now, solving the equations. When you're solving them, you're still going to use the factoring, but you'll notice the difference in the, we've gone from an expression to an equation. The expressions don't have this part right here. That's an expression where it's not set equal to 0. Once you set it equal to 0, it's now an equation. So you're going to do all the same things that we've been doing, except when you get down to the very end, you have to solve for the 2 different answers. So we want to go through all those same checklists of factoring that we've been doing. First of all, is the first, there's only 2 terms here. And the first term, and there is a subtraction in the middle. So this could be the difference of 2 squares. But that first term is not a perfect square. But I also noticed that I could factor out an 11 out of both of the terms. So let's start there and factor that 11 out. And once I factor 11 out of 11q squared, it leaves me q squared. And when I factor an 11 out of the negative 44, it leaves me a minus 4. And q squared minus 4 is one of those special factoring patterns that we've talked about. It's the difference of two perfect squares. So the square root of q squared is q. What's the square root of 4?
2.
So I would have the q plus 2 and the q minus 2 equals 0. The difference when we were just factoring before and we didn't have that equals 0 part, we were done. Once you factored, we were done. But now that we have the equals 0, we have to take the two small factors, which are just small algebra problems. We set each one of them equal to 0 and solve for the variable. What most students notice after a while is that you're just basically taking the inverse of each of what's inside. So what this tells me is the solutions are -2 and 2. And what that means, these are the solutions. These are the roots. These are the zeros. And they're also the x-intercepts to a quadratic function. They are called all 4 of those things. Okay? So if it says solve, what you're looking for are the roots, the zeros, or the x-intercepts. So what that means is if I were to graph this parabola would actually cross at -2 and 2 on the x-intercept, on the x-axis.
Is that what
okay?
that worksheet is for?
Yes. So that's so that you all will understand like the connection, like why are we now all of a sudden factoring? How does that connect with all these goofy graphs that we've been drawing? And that's the connection, that they literally cross at those places. And that's what it means when it says to solve the quadratic equation. That's what it means. So you're still factoring. If it says solve by factoring, obviously you're going to factor that quadratic equation, but then you're not done if it says solve. You don't end there. You have to actually tell what those solutions would be, which tell you where it crosses the x-axis or what the roots or zeros are. All right, that was 33.
Mm-hmm.
And now we're going to do 35. And I think that's the last one, right?
Mm-hmm.
So we have 45n squared plus 10n equals 0. Okay, this is like the one where we had the u's on number 25. We can factor out a number and a letter. So what number and letter can we factor out of both 45n squared and 10n?
5.
5 is the number and the letter
N.
So when we take a 5n out of 45n squared, that would leave us with 9n. And then plus, when we take a 5n out of 10n, 2 equals 0. And now, believe it or not, each of these are two small algebra problems that you have to set each individual factor equal to 0. So divide both sides by 5, and that gives me n equals 0. And then take 9n plus 2 and set it equal to 0. Divide both sides here by 9. And my final answer is n equals -2/9 on that one. So my two answers are 0 and -2/9. So that would be where this parabola would cross the x-axis. Those are its roots, its solutions, its zeros, its x-intercepts.
Mm-hmm. I think I can do the worksheets on my own.
Okay.
Thanks so much.
Did this help?
Yeah, it really did.
Oh, good. Good. I'm glad. Well, I won't see you in class tomorrow, but I will be on Math Lab on Tuesday if you need me.
Okay.
Okay. But have a great Labor Day weekend.
You too. Bye.
All right. Bye-bye.